Good morning, Julia.
Good morning. How are you?
How are you?
Doing
Oh,
well.
we said it at the same time, so I guess we'll have to say it at the same time. I'm great. Come on. I'm great.
Yes, me too. Me too.
So we have an exciting show
I know.
today.
Authors of a math book. How exciting.
Authors of a nationally renowned math book, as a matter of fact. Traditional math, an effective strategy that teachers feel guilty using. And we have with us today Barry Garelick and J.R. Wilson. And I will say I have known Mr. Wilson for a number of years. He is a math teacher and has been a math teacher. And so is Mr. Garelick. And so I'm going to read to you a little bit from their book. This is the inside cover of the book, which, by the way, I have, and it's quite the wonderful book. So Mr. Wilson has 30 plus years experience in working in public education as an elementary classroom teacher, middle and high school math teacher, State Department of Education curriculum consultant, regional education service agency staff development coordinator, and elementary principal, among many things. And the way I got to know Mr. Wilson was we were both interested in Common Core, and Mr. Wilson participated in coordinated reviews of the draft of the Common Core math standards and state standards. And he's retired, but he and his wife are residents of the Pacific Northwest. So he's up very early this morning. And Mr. Garelick taught 7th and 8th grade math for 10 years as a second career after retiring from the federal government, where he worked in environmental protection. He majored in math at the University of Michigan and is the author of several books on math education, including his most recent, Out on Good Behavior, Teaching Math While Looking Over Your Shoulder, published by John Catt. He and his wife reside in the central coastal area of California. So we have two West Coast people on today who have gotten up quite early this morning to be on with us. And so welcome, Mr. Wilson. How are you this morning?
I'm doing great.
Excellent. And Mr. Garelick, how are you this morning?
I'm fine, thanks.
Excellent. We are so excited to have you this morning. I actually was given the book by my friend, Mr. Wilson, and I have looked at the book. And this morning, before we went on, I was bemoaning the fact that I didn't have this while I was educating my kids at home. Because this is a stellar book. I mean, it's literally a stellar book. I'm just going to say a couple of words about it before I bring you guys in, because we both want to ask you some questions about it. But this book was wonderful because it's simple without being simplistic. So there are examples that are easy to understand. It doesn't go, there's enough explanation so that you actually understand what they're saying. And the best part about it was there are actual problems that you can solve, warm-ups in there where there are actual math examples, math equations, and you can work on those. So I love the title. The subtitle of the book is An Effective Strategy That Teachers Feel Guilty Using. So I'm just curious, why the subtitle?
Well, now my co-author here does not feel guilty while teaching it. I'm newer at it than he is. He taught for 30 years. And as you pointed out in the bio, this was a second career for me. And in education schools, there's an indoctrination that traditional taught math is held in disdain, that you're told, well, it's not effective, it's all lecture, it's all rote, there's no understanding, and so forth and so on. And then you're taught other methods to use. And so I'm not the only one who has experienced this, although I teach in the way that I feel is effective, and which is described in the book. There were some feelings as I did this, that, oh, gee, is this the best way? And I've read from other people that they had this same feeling that of guilt, that, gee, should I be doing it this way? And so that's how I picked the subtitle, that, yeah, this is an effective method, but some teachers feel guilty using it because of the disdain that traditional math has acquired over the years.
So I'm curious. So James, I'm going to flip it to you. As a 30-year educator, why do you suppose there is such disdain for a traditional math, more traditional math type study?
Oh, that's a question that really eludes me. I think just over time, people wanted to make changes in things for whatever reason. I want to add to the teaching, feeling guilty about teaching traditional math. Barry does mention in the book that he would feel vaguely guilty teaching a traditional method. He's even written a humor-filled book that you mentioned, Jenny, called Out on Good Behavior, Teaching Math While Looking Over Your Shoulder. And that, brings out some of the way that guilt, or dealing with that guilt, was done. On the other hand, I never felt guilty, not even vaguely, about teaching math in a traditional manner. Even though Barry and I are of the same generation, we entered the teaching profession at very different times. I started teaching in the mid-'70s, and teaching math in a traditional manner was just the way it was taught then. And Barry entered the profession after retiring from his first career, and things had changed considerably. So his ed school orientation was quite different than my experience decades earlier. And as far as I'm concerned, we're really fortunate that the attempts to indoctrinate Barry weren't successful. Otherwise, we wouldn't have this book.
It's very interesting to me. And I think the people that are watching, and we have numerous people watching at this point, I think that's probably the most interesting thing to people. And I'm going to kind of build on what you guys just said a second ago. So we were talking before we got on about the fact that when we had done, oh, Barry, tell me what the name of the process is again. Binomial.
Oh, you're squaring a binomial.
Yes. Okay.
Yes.
So when I tried to teach that, it sounds like it's ridiculous for me to have taught it since I can't even think of what the name of it is. But I will say that I was in considerably better practice while my kids were at home. But we used Saxon math at the time, and that's pretty much what I took all of the kids through. And when we got to the squaring of binomials, I learned a method when I was in high school called FOIL, which was first, outer, inner, last, and that's the way you multiplied all four of the numbers in that equation. And that's not the way this book that we were doing with Saxon had it. And it was so convoluted. And the kids were like, I have no idea what they're doing here. So I taught them FOIL and they were like, oh, wow, this is great. This is so much easier. I totally get it. First, outer, inner, last. So is that kind of what we're talking? Is that a fairly decent example to use when we come down to what we call traditional math?
Now, I would be careful there because I do talk about the FOIL method in the book. But when I start teaching it, I teach a different way of doing it, which will work for any two polynomials. So let's say you have x plus y times y plus 2 plus z. You've got a trinomial. The FOIL is going to be hard to apply there.
True.
So I teach probably the way Saxon did it, where and it's hard to do it without a whiteboard here, but you're using the distributive rule. And I show how to do that, and the kids do that, and we go through a bunch of problems. And then sometime later, I'll show them the FOIL method. And I always preface it with, you're going to say, how come you didn't teach us this method first? And the answer is because the first method will work for any two polynomials. Whereas if you've got two binomials, FOIL is probably the easiest way to do it. Now, the reason I like FOIL is because when you get into factoring, which is the reverse of multiplying, so you have a trinomial and you're saying, what two binomials can you factor this into? Then you're doing a reverse of the FOIL method. And that's how I explain it. And some kids will just say, oh, this is just FOIL backwards. And it works because they know how to do it frontwards. And so now they do the computations in their head. Okay, what numbers add to 6 and multiply, you get whatever. And so they get into the mental framework to do those problems. So that's why I find FOIL helpful. And I've had teachers say, oh, we shouldn't teach FOIL because it obscures the understanding. And I just haven't seen that to be the case.
See, that's very interesting. So let me ask you, James. So why did you guys write the book?
Well, I think because of our experience and seeing how traditional math is viewed by a lot of people, it's mischaracterized a lot. And we wanted to share our approach to teaching traditional math that we use, to help our students become successful in developing understanding, and the way we teach math in a traditional method actually dispels the mischaracterizations that a lot of people have about traditional math. And more recent cognitive research findings support our approach, so that we thought it might be helpful to others if we shared our approach.
Excellent. Years and years ago, and Julia and I and one of our other colleagues used to go to an educational policy conference in St. Louis that they had every January. And one year we went, and I ran into a man named Stan Hartzler, who actually had taught math in Oklahoma. And and he had taught math in Oklahoma in the 80s, and he had used traditional methods and actually increased the test scores of the kids in 7th, 8th, and 9th grade where he was, teaching, just by using some of the more traditional methods. And so I was wondering, what kind of methods do you feel like really help bring about understanding in kids? And I'll just throw that up to either one of you.
Well, I'll start off,
Okay.
and Barry can jump in and add. There, I think you have to build a foundation, and that starts in the early grades. And it's important to have students learn and become fluent with the basic math facts.
Yeah.
And doing that is a major contributor to their success. Other things that I feel help my students become successful in math includes, having students set goals, having consistent daily practice that would be very intense but of short duration, um, having leveled practice, focusing on one fact or skill at a time, and having students check their own work, um, and in doing so, getting immediate feedback, and keeping a record of their progress, and having an ability to move up to a new level when an established proficiency goal has been reached. Another thing that I would do, and I think Barry also would do, is use a method that we refer to as I do, we do, you do. And in the I do part, that's where I might introduce a particular skill or a new type of problem, and I would work through several examples to show the kids, and as I'm working through them, I would explain what I'm doing and why I would be doing it. And then after I'd worked through several examples, I would give the students a problem just like the kind I had been working, and that would be guided practice. And then after they would have a chance to try to work the problem, then I would work the problem for the class and explain the steps. So if they didn't get it, then that's okay, because they usually knew that, hey, we're going to work through several more of these problems. So we'd cycle through that several times until the students were ready to do some work independently. And that would be the you do part, where they'd have a set of problems, just like what we had been working on in the I do and we do part. I would use the I do, we do, you do to pre-teach some skills before we get to actually get to them. And I'd use that to prep for current work. And then I would also use that to backfill deficiencies that I would see a lot of students would have. And all the time working through that, be asking lots of questions like, what should I do next? Why? That kind of thing. And I actually, after I'd been using that method for quite a number of years, I came across an instructional framework called the gradual release of responsibility, which actually incorporates this I do, we do, you do method.
Very
Barry,
good.
do you have some to add to that?
Yeah, we do use that. I use that method. And in the you do stage, if you've gone through the book, you'll see that when we get to the you do stage, I give them lots of problems. And I don't just set them out on their own. It's kind of a hybrid we do, you do type of thing, because they're going to struggle at first because it's new. Some people say, well, it's just imitation. Well, if you've ever learned to dance or how to bowl or golf, imitation is harder than it looks. So when you see the teacher doing it and then the class is doing it as a whole, oh yeah, this is simple. Get on your own. Well, gee, this is a little harder than I thought. So you work with the students, you go around the room, make sure they're doing the problems right. And it isn't just the same problems over and over. I like to up the ante so it gets a little more complicated. It's not the first initial worked example. You add some complexity to it so that they're kind of making these leaps of reasoning. Once they get the confidence, I can do this, then they're ready to take some leaps. So that's in the you do stage. So there's a lot more to it. And I also like the you do stage to be a preface to the homework. And in fact, I start the homework. The you do can actually include the homework. I like to start the homework in class so they don't go home and say, how do you do this again? So they've already started on the homework. They've already got the feel for it. And then some kids figure out, gee, if I do all these problems now in the remaining time, I won't have to do any homework at home. It's like this big realization.
I was always so good at that. I could always get all of my homework done before I got home because my time after school was my time after school.
Exactly.
But I worked like a dog during school.
Yeah.
So I want to back up to something James said. And as I was a public educator for many years. I've got biology degrees, but I noticed my mother was a 34-year English teacher. And I noticed that over the years, what was happening with English and teaching English was we quit doing things like diagramming sentences, and we quit doing actual spelling. I'm not kidding. I mean, literally, there are many classrooms where they don't even do spelling anymore because why would you? There's, Word and you can just do spell check. So to me, as a not just a public school teacher, but as a homeschool teacher, I was really kind of aghast at the amount of just basic fundamental skills that have suddenly just gone the way of the dinosaur. And James, I was really super interested in what you had to say, because the first thing that you said before you said anything else was kids need to learn their math facts.
Yep.
So what happens when you don't have that foundation? Because I think we could all sit here as talking heads, for hours and talk about, well, we could do this better, we could do that better, we could do this better. But the kid has the ultimate responsibility, really. I mean, if you think about it like that, and their ultimate responsibility, hopefully with the help of their parents or guardian, is to learn their math facts, right?
Yes, I agree. Although, for me to say the kid has the ultimate responsibility, I think that would hold true as kids get older. But I started teaching primary grades, and I would have a problem with the kids being responsible for that. They need a lot of guidance and a lot of help, and they don't know that they need to know their math facts. So one of the things that and I get into this in the book, that I even will tell parents to work on at home, is have kids do skip counting, count by twos, count by threes. If you get proficient counting by twos, then move to threes. And I would encourage them not only to do that, but to have kids write out like a 1 minute timed drill, where they would write skip counting by twos to 10 or to 20 as fast as they can and as many times as they can in 1 minute. And that helps with the writing fluency, because with a lot of time tests, a lot of times kids, their ability to write and work problems, they're slowed down because they're not used to having to write fast. And so that helps, learning the skip count. When they learn skip count, they've learned their multiplication facts.
Yes.
And so you learn your twos. Usually kids, kindergarten, first grade, they've learned to count by twos, count by fives, count by tens. So, you begin adding, count by threes, count by fours, and the others start coming easier because, well, counting by eights that's only half of the numbers that you use when you count by fours. And so they learn that, and then have them do multiplication problems on a time, and not mixed problems. If they're working on learning their twos, just have them work on problems where they're multiplying by two.
I'm just curious. I think I know the answer, but I'd like to hear it from you and Barry, whoever one of you wants to take this. So why is it, my kids used to ask me this, why are you making me do my math facts in 60 seconds, right? I mean, why do 50 math facts in 60 seconds or whatever? What is you have a lot of people today saying, we don't need to put that pressure on kids to know those. Why is that important?
Well, I think I'll let Barry talk about. I'm sure he's going to talk about getting that imprinted or ingrained into long-term memory. But one part of that for me is you're doing something very intensely for a very short duration. You don't want to do it too long because that's just going to turn the kids off. But if they know that, hey, I can do this, it's only going to last a minute and then I'm done.
Barry?
Yeah, I agree. Yeah, you don't do it to death. But it's important to build up the speed because otherwise, and I've seen this, the kid's doing a problem and he comes to 8 times 7 and it just halts and then you're stuck. The whole idea is to make it automatic in the working memory. It's got to be in long-term memory. Working memory is where you do the thinking. So you don't want to clog up that working memory with trying to remember the facts and then you lose sight of the problem that you're trying to solve. So it's very important to have that automaticity. So that's where the speed comes in. It's to develop that automaticity. Now, I taught 7th and 8th grades, and I had one year a group of 7th graders that had some pretty significant deficits with their math facts. And so I would do the minute type quiz, and they'd have the sheet and I'd say, go. And the kids are competitive, and I hear all this stuff. Well, it makes them feel bad and this and that. They were competing. They loved it. Like, can we do these today? And then I put the top 3 names. Obviously, I wouldn't put the lowest score. You're not going to make somebody feel bad. But the top 3 scores, and they'd be vying to get up to the top. So you can make a game out of it.
Absolutely. I've always thought math was just like working a puzzle. And you can actually get in a real answer, which, English and literature and things like that, when you're learning those things, they're subjective. One of the things my husband used to do when our kids were very, very young, preschool, he would pull the change out of his pocket and throw it on the coffee table and say, if you can count it, you can keep it.
That's good.
So he taught them math skills very young, and it was kind of like, the different, the pennies, the nickels, the dimes, the quarters, whatever it was, they had to figure out, how to count it, and they did.
Yeah.
They got good at it real quick.
And it's kind of funny going back to what you said, Barry, about competition, because, even I had 2 that were essentially in the same grade. This is just me as a homeschool mom. I had 2 essentially in the same grade. Oh gosh, no, 3 at one time, essentially in the same grade. And then a younger one. And he just was not ready, to move up with the other 3. But it was so interesting when I'd make them do time tests, because the three of them were all competing, right? I mean, they just wanted to see, because I'd always do something like, whoever gets done gets a piece of candy for today, or gets $1, or, I just do something to throw it out there to make the competition, even more thrilling.
Yeah.
And, it was funny that, even the little one then wanted to do what they were doing. So why do you think, I mean, this is probably off topic a little bit, but why do you think competition has gotten such a bad name? I mean, we do it in sports. I mean, why can't we do it in the classroom?
Well, I think, the issue of time tests gets kind of ambiguous. There's the type that we're talking about where you're trying to master the math facts, and I never counted it as part of their grade. I just wanted it for them to see their progress, keep track of their scores, and you see it improve over time. The other part of it is you have to give quizzes and tests as part of class, and it's part of the grade. And then you hear, well, this causes anxiety. Well, of course it does. I majored in math, and I got anxious whenever I had to take a math test. Just because you like the subject doesn't mean you don't get anxious. But you have to learn how to deal with it. You're preparing them for high school. You're preparing them for college. Now, as we discussed earlier, I was new to teaching. I didn't have the years of experience that JR does. So the problem I had is sometimes I would make tests too long, and they couldn't finish it in the class period. Some kids couldn't. So it's okay, I'll allot some time for tomorrow to finish the test. So they didn't feel this burden. After a while, I learned how to pace the tests better so they get it all done. But there's ways of dealing with the anxiety. Now, some kids do have honest to goodness math anxiety. I had this one boy who was very bright, and in class he'd come up with the answers, and you'd ask him a question, sit him down in the test, and he'd forget his math facts. He'd start crying. I mean, this is in 7th grade. He said, I don't know. What's 8 times 7? I don't know. So I'd have to just sit with him, work through the first few problems, and then he'd relax and say, okay, I'm okay now. So yeah, it's a real thing for some kids. But I think a lot of it is overblown, that some anxiety is normal. You're going to have anxiety in your life and dealing with stressful situations. So you've got to get them prepared for that.
I'd like
ahead,
to talk about the competition. What I saw with most of my students when I was teaching 6th grade is they were competing against themselves, not each other. And some of that would come from they would keep a record of how they would do each time we would do, say, one of these little drills on skip counting. And they would be able to see from one day to the next how they were doing and see progress. And they would start setting a goal, hey, I want to beat what I did yesterday. And so they would compete with themselves, not so much with other students. Although I, would have to say that when we would do, I do, we do, you do, in the we do part, there would kind of be some competition to see who could finish the problem first.
And competition is healthy. I mean, it is kind of nice, but that is another good point though that you raise, James, is that that's the other thing I kind of feel like that stopped, and we can talk to Sandy more about this too, since she's, finishing up and currently in the classroom, finishing up her PhD and currently in the classroom. When I was a kid, you had a scratch sheet and you were able to, you'd have your time test, but you'd have a scratch sheet there just in case you needed something. And so much of this happened where you could write things down and you could look at what you were doing and you had an idea of how well you were doing. And so much of it now seems to be done, on the computer as opposed to, actually written out. And to me, I'm not that kind of a person. I need to have the writing out. That works for me. Trying to do math on a computer, it doesn't compute for me. So I'm just curious, do you find kind of the same thing? I mean, do you feel like it's better to get them writing on something? Because one of the things that my mother used to teach me for years was part of the reason why you used your hand and you wrote is because this was attached to this.
Yeah.
So this was helping you remember what you were doing. So anybody?
Well, if you write down your grocery list and you get to the grocery store and you realize, oh, I left the list at home on the table, you can probably remember most of the things you had on the list simply because you wrote them down.
Yep.
I would, with the I do, we do, you do that I would use, I call that scratch paper time. I would tell the kids, get out some scratch paper, or I'd just say it, I'd just announce it's scratch paper time. And they knew that I wasn't going to collect those papers. It was their work. It was for them. I would look at it as they would be working problems, and I'd go around the class and look and see how they do. But I would also, in the I do part, when I'd introduce something, I would show the steps and write out the steps of a problem like I would expect the students to do, so that any one student could look at another student's work and follow what they had done instead of it just being a jumbled mess. And I think I think my students benefited from that.
Yeah, I would say writing things down is extremely important. I would have students keep a notebook, and I'd go through the presentation, the lesson, the first part, and with the examples, and they write the examples in the notebook, but also some key definitions, write them down. So I think that's very important. Also, showing your work. This is always a big issue. Why do I have to show my work? Because you could retrace your steps. This whole idea of explain your answer, the math itself is the explanation. And if you could show the steps that you use to solve the problem, you have provided an explanation of how you solve this problem. And so, as James said, it's important that they see how to write down these steps and get them in the habit of it. Kids don't like to do that because they're in a hurry. But you really have to instill that as a habit. There was one teacher that I worked with who said, if you don't show your work on a test and you get the right answer, it's going to be wrong unless you show what you did. I wasn't quite that tough. Maybe a few more years I would be. But I think it's important for them to understand. The other thing I would tell them is, okay, let's say you get a wrong answer. But if you show the steps and I see that you had the right idea, you just made a numerical error, you'll get partial credit. But if you don't show your steps and you get the wrong answer, you don't get any points. And that would make an impression on them.
That's so funny because you became my favorite person. And I wish I had you there when I was struggling with my son, who's now getting a computer programming degree and doing way, advanced math. But, when we were doing basic algebra, it's like, buddy, you can't just put, the answer. You have to show me what you're doing, because how else will we know where you went wrong? Right. If you don't put the answer down. And you're right. It's almost like pulling teeth to get them to want to show the answer when, therein lies all of your teaching is in the answer that they're writing out.
Right.
So
I would find with my students that when they would show their work, when we would check, they would check their own papers in class. If they would miss something, that they could go through the steps that they had written out and oftentimes find where they got off track. And if they couldn't, then they'd ask me to work through the problem for them. And in terms of understanding, and Barry mentioned this, that math is a language, and showing the steps of the work is using the language of math to explain what you've done. In the book, Adding It Up, Helping Children Learn Mathematics, it states, quote, students often understand before they can verbalize that understanding, unquote. So without having to verbalize, students explain and show understanding when they show the steps of their work using the language of math. And I think if you press kids to have to write out, an essay or verbally explain some things in terms of their understanding, they're not ready. They're oftentimes not ready for that.
That's awesome. So I've got another question for you, and I was just wondering. So when you wrote this book, who were you writing it for? I mean, did you have an audience in mind when you were writing it?
Yeah, I wrote it for you, Jenny.
You were too late, James.
Actually, it is a book that you mentioned that you wish,
Yes.
you would have had it years ago, and I wish I would have had it when I first started teaching, except I didn't have the experience to write it back then. But really, the target audience for this book includes teachers, parents, homeschoolers, and actually anyone who wants to brush up on basic math skills and develop a better understanding of the math concepts. And it was written as kind of a resource or a reference book. It's not written with the intention that somebody's going to pick it up and read it from cover to cover. Now, there will be a few people that may do that, but most people, hopefully would pick up the book, look at it, read some at the beginning of the book, and then look and see how it's organized so that they know what's in there, so that when they need something, they can find it in there.
Yeah, I'm going to say, before you say something, Barry, let me just jump off on that. One of the things that I am planning on doing, my youngest son took the SAT, and while he understands math, Barry, you talked a little bit about people who have math anxiety, and that kid unfortunately has that, and test taking anxiety. And so he just gets a block when he does, and he can do English fine, but not with math. And I was going to take that book and give it to him to go over some of the basics, to go over that again, because it's so well done. So I think anybody who's going to take, anybody who is, or anybody who has a kid who's going to take a PSAT or an SAT or an ACT or something like that, this is a great book to brush up on all that math that is going to be absolutely necessary to be able to get a really good grade on any of those tests. So sorry, I just wanted to, okay, Barry.
No, that's fine. I think another reason that I took it on was there are all sorts of books about various types of math, project-based learning and inquiry-based learning. And you don't see any, as I said, the traditional math is held in disdain. And I wanted a book to show what it looks like in the classroom and to dispel some of these myths that it's all rote understanding and all rote memorization and no understanding. And if you go through the book, you'll see there are explanations for why you're doing what you do. I don't obsess over that because kids want to know how to do it and they get into the procedure. But it's there. We do teach for understanding. I wanted people to see that. I wanted them to see how traditional taught math looks like, and that it isn't this horrible thing that people say it is.
So I'm going to back up a second, Barry, and talk about, well, you mentioned project-based learning. And I think one of the things that Julia and I run into a lot when we talk to parents, and especially me as a homeschooler, because I've got, I've got feet in both the public ed and the homeschool communities. Parents, especially moms, I think, have a hard time. Well, they don't believe they can do math. A lot of people anymore don't believe they can do math. And I think kind of women have some kind of something there, which is, I don't believe I can do math. I don't understand math. If you've got a mom at home and there are papers coming home from a kid, and let's keep it, because we all were in, I taught 7th grade for 4 years. So let's stick to kind of that middle, elementary grade area. So if you see stuff coming home as a mom, do you have any kind of pieces of wisdom you might impart to parents to let them know the difference between maybe project-based learning and what traditional math looks like? Does that seem like a question? Did it come out right?
Yeah, I think I know what you're saying. I don't want to get too far into other techniques. Basically, one thing I hear from parents is, I don't know what they're doing because they don't have a textbook, and I can't tell what they're doing from what they bring home. Whereas with traditional math, there is a specific order to things. I use a textbook, but I supplement it. But I will always, the students will have the material they need, and they've got the notebook, which has the instructions in it. If I'm supplementing it, it isn't in the textbook. But the parents will have a way to check on what their students are doing. I give them homework. There's specific problems that they need to solve, whether it's in the textbook or a worksheet. It's there, so the parents can see what it is their kids are doing.
So then let me make sure that I understand this. So if you're a parent and your kid is in a math class, the thing that you want to advocate for is a math book.
I think textbooks are very important. Some are better than others, but you want to have something that so you know where you are. Now, I deviate from textbooks a lot, and I think James probably does too. But the thing is, if you're on the lesson on discounts and you can find it on page so-and-so in the textbook, you know that that's what they're doing. Now, maybe I supplement it with a bit more information that isn't in the book. The thing is, the book is the basis. It's the sequence, and it's your blueprint. Where are you in this class?
Right. Yeah. So I guess my last question, then I'm going to let you guys close it out. Do you have any, because this is another question I get asked as a homeschool parent all the time, what kind of math do you use? Because there are a million different math books out there, and I had my favorite, and you've got some that are in one camp as opposed to one that is in another camp. But I think it's really helpful for teachers of math, especially traditional math, to say what they like. So are you guys comfortable with saying kind of what you guys like to help parents get an idea?
Go ahead, Barry.
Well, with the algebra, and I mentioned this in the book Traditional Math, I bought a bunch of books over the internet, a book by Dulciani that was used for many years, and that's what I would use in the classroom. I mean, I bought them over the internet and hand them out. And I found it was better than most of the contemporary math textbooks. I liked the sequencing of it, and I liked the problems that Dulciani has in it. As far
How do you spell that, Barry?
Dolciani, Dulciani, Mary Dulciani. So I used that. In 7th grade, I get this question a lot, and there's various forums. I can't keep track of, there's the Beast Academy that people recommend. I haven't used it. Singapore has some good books that you can get, you can order. I used Singapore's primary math with my daughter at home. But I would generally go with the textbook and supplement from things like Singapore and other books. But there was no book that I would buy over the internet like I did with the algebra class. So it really varies. But I would say it's really important for the teacher to have the content mastered, to know the math that they're teaching.
Yes.
And this becomes more of an issue I've heard in the lower grades, because teachers have to teach not just math, but history and science and all that. With the 7th and 8th grades, middle school, all you're teaching is math. And maybe James can elaborate on that.
Well,
James.
In terms of math books, I like Saxon and Singapore, although those are textbooks that I never had the opportunity to use in the classroom. And I usually use just whatever was had been adopted by the district that I was teaching in. And those were usually pretty good textbooks up until some point in time where I'd say I started seeing things change in the early 2000s, and some textbooks being adopted that were just not worthy of being used, but yet I had to use them. And as Barry mentioned, it's important for the teachers to know the math that they're going to be teaching, and I think it's important for them to know the math beyond what they're teaching, so that they know what's important. And I call that separating the wheat from the chaff. Because early in my teaching career, I was teaching 2nd grade, and the adopted textbook was kind of with the new math back in the 70s, late 70s. And it had kids in 2nd grade working problems using base 8. And that just didn't make any sense to me. So it was like, okay, because it was in the book, I was supposed to teach it. We touched on it, but we didn't dwell on it. And actually, it was, I think, one of the purposes of having students work with base 8 was to help them better understand place value. Well, what I found was that only made my students more confused, and it definitely confused their parents.
Kind of sounds like Common Core math, because, I know that you and I particularly were, interested in Common Core. And one of the problems, with Common Core was it just wasn't developmentally appropriate. They were trying to use methods on kids that kids just weren't really ready for.
Yeah, I'd like to talk about that for a minute.
Oh, okay, sure.
Because with Common Core, and James and I worked on providing comments when the Common Core was a draft and so forth. One thing that isn't made clear is you'll have a standard like 4th grade, where the standard algorithm for multi-digit addition or subtraction is part of that grade standard. And it's been interpreted that, you can't teach the standard algorithm for adding and subtracting multi-digit numbers until 4th grade. And I've had that clarified by the authors of the math section of Common Core that no, there's no prohibition. You could teach it earlier. And you should. And the way James and I learned it, and probably you, is you had the standard algorithm presented first. And you could look in the old textbooks. I've ordered mine, and there's explanations of what's going on with the standard algorithm. It doesn't obscure the understanding as some people claim it does. After students have mastered this, maybe in the next grade or two, you learn these same things that are in Common Core. There's one strategy called making tens. I'm not going to go into what that is, but I had that. I've seen it in the textbook. But you've got the anchor, you've got the standard algorithm. This allows you to explore a little bit. If you want to use that method as a shortcut, you can, but you've got that anchor there. It wasn't imposed that you had to do it for weeks on end. It was just there. So I would say, because I've had this question, is your book compatible with Common Core? And I think it is, because there's no prohibition on when you should be teaching these the standard algorithms. And I do have sections in the book that talk about, oh, Common Core requires this, and so this is how we handle it, just so people are aware of it. So I just wanted to say that.
That's awesome. Are you guys going to be able to stay just a second while we bring our friend Sandy Harrell in?
Yeah.
I can.
Perfect. Okay.
Before we get too late, though, I want to be sure. I know you can get your book on Amazon.
Oh, yeah.
Where else can you get your book?
Oh, there's a bunch of outlets. If you don't like Amazon, you could use Barnes and Noble. There's any number of outlets where you could buy books over the internet. So just pick your favorite outlet and look it up. Traditional math.
Good.
You should be able to find it.
Perfect. Okay, well, I'm going to take this second then and bring in our friend Sandy Harrell. Sandy, as I mentioned before, we've known Sandy, oh gosh, way back to the Common Core years. And Sandy is, you were a math instructor before you went to get your PhD, right?
Yes.
How did that work?
Yeah, I've taught middle school for about 22 years, and I've taught multiple subjects, science, English, mostly math, but every subject at some point in my career, because I teach in small rural schools. And so when you usually work there, you have to wear several hats. So, yeah.
Gotcha. Well, I noticed it because Sandy and I were chatting just a little bit while you guys were talking. So you like the IWU strategy that the guys are talking about.
Yes, and I found this book to be, if I had to use a word, I would say validating, because as they were saying, when you teach traditional methods, you're old, you're outdated, you're antiquated, and that doesn't work. And I think if they were to come in and see the attitude of my students, they're by and large, I mean, it's middle school, so some days they're just miserable because they choose that. But by and large, they don't hate math. They're, pleasant, they're excited, they're positive, and so they have a good attitude about it. And I think because the structure, the expectation, step by step, and I think it has benefits that particularly cater to middle school. And as far as showing the steps and showing the work, that is so crucial in middle school, because they're just so used to TikTok and swiping, and they don't dwell on anything for more than 5 seconds if you don't force them. So if their problems and everything are on a computer screen, they're just going to click and go, and if they miss it, they miss it. But if you actually force them to go on paper, and as you were saying, they check their own work and they self-evaluate. And so what's funny is a lot of times, especially I found this to be the case with boys, if they get two different answers, they'll say, hey, which one of us is right? And I'll say, well, I'm going to say right now you're both wrong, and you show me your work and convince me who's right. And so usually in the process of their, going, oh, well, I did this, and then second this, and then, and then they find their own work as they're explaining it to me. And so they'll say, okay, just a second, they'll fix it. Okay. And I said, well, now you have the same answer. So either you're both right or you're both wrong. So then they'll kind of come together and say, yeah, we think we're both right because we both, processed it this way. So it's kind of fun to see that happen in middle school.
Well, but not only is that fun to see that happen, that's where actual learning happens.
Correct. Yes.
That's where the rubber meets the road. That's where the kid goes home and goes, man, I worked through this whole problem until I could figure out what was wrong with it. And now I know what I'm doing.
Yes.
So that's great stuff. So you guys, isn't this great that you have the math teacher right here who is calling your book validating?
And that IWU method, I mean, you could have written that, for my classroom in May. I mean, that's what we do. Because as you said, that's how you learn to do something new. You see it demonstrated, then you start participating, and then you start working independently. And so as I'm going through there, and I call it, gradually taking off the training wheels. You have your training wheels and your guide rails as you're going, but, when you take those off at some point, you got to pedal. And so you're making your own way. So it's just, teaching them a little bit of, the logical process, the reasoning process, how to question yourself through something. And so I've taken a lot of notes here as you guys were talking, but particularly with math anxiety. And I think a lot of that pertains to getting started. Because a lot of times if they can know where to start, where to begin. And so if they, get bogged down, okay, what do you do first? just talk about what do you do first? Because especially if they know, like if they're solving an equation, they already know there's going to be 6 steps there. Well, just worry about step 1. And then what's next and what's next. So that helps with a lot of them that have, anxiety, which especially since COVID, our number of students who have been diagnosed with ADHD and math anxiety has just skyrocketed. And I think, this is just my theory, I'll have to prove it later when I have more time. But when this process, when we shut down for COVID, did not translate well. And so if you're a math teacher and you're just like, oh, get online and do 20 questions, well, yeah, they're going to get on there and click 20 somethings, but you haven't seen what they've done because they're probably not, if nobody's standing over them to make them, you're going to process that out, write that out, and go through the actual process like they would if they were in the classroom. And so depending on where your school was shut down, or even when we opened back up, the quarantine guidelines were such that we'd have kids miss 20 days of school or more. But we just kept pushing them on to the next grade and the next grade and the next grade. So those gaps are now huge. So it's you find yourself having to do a lot of, I think the word used in the book was maybe backfilling, things that they should come to you knowing, but they don't. And especially like you were talking about, Jenny, with the reading and the letters and vocabulary, that's, yes, the exact equivalent of times tables. So if they don't know their multiplication facts quickly, they're very likely going to get bogged down in that process. And so if it's a multiple step process anyway, but now you've exacerbated it by not knowing your times tables, now you feel overwhelmed, that anxiety is going to kick in, that ADHD is going to see that squirrel because you're just looking for a squirrel and waiting for a squirrel because you're, get me out of here and help, because you get overwhelmed. So yeah, it's, having them show the work on paper is crucial. And I just think that during COVID, that exchange and that process and that conversation was lost.
Well, I love sitting here listening to you guys. I mean, just hearing math teachers talk, it's like, I feel like I ought to just let you guys go and talk to one another and let us overhear. If all 3 of you, what is the thing that parents can do most to help kids? I mean, my intuition tells me that it's no matter how much crying, no matter how much protestation, no matter what's going on, you make them learn those addition, subtraction, multiplication, and division facts. Now, that's just me, but you guys take it.
Well, I think I don't like to put a lot of blame on parents. There's things that they can do at home, and if they want to work with their kids, that's great. I encourage it. But I remember going to a back to school night in 4th grade, and the 4th grade teacher saying to the parents, your kids don't know their math facts. Like it was our fault. And I don't think that's fair. There's got to be some give and take. Now, James has his way of instilling that they know their math facts. And he says, have them skip count. And yes, the parents can work with their kids at home, and they should. So I think parents should be encouraged, but I'm really against making parents feel guilty if they don't. Now, some parents both work jobs and they're tired, and maybe they don't know math as well. And sometimes they can't provide this help. So I'm really careful about what I say about what parents can do. So you give them some guidelines, or here's some exercises you could work with your kids at home. So give them some structure, some guidance on how to work with their kids, and don't just expect them to know how to work with their kids at home. If you want to help them with homework, I encourage that. It's great. Some parents can't, so you have to recognize that.
Yeah, I would, if a parent asks for something, some help or ideas that they could use at home with their kid, I would work with that parent. But I would tell when I was teaching 6th grade, I would tell my 6th graders that the chances of their parents being able to help them with their math at home was probably fairly slim. Tell them that, when your parents were in 6th grade, they could do this stuff, but a lot of your parents haven't used it, and they're going to struggle trying to help you. You're going to know more of it than they are. And with the population of students that I usually work with, that was pretty much the case.
Well, I think part of it may depend on where you are nationally, what state you're in. For example, in Oklahoma, starting in 6th grade, kids now get to use calculators on the state test. And we just implemented that a couple of years ago. And I think when we did that, it changed the perception of the importance of learning those facts, because I think perhaps at the elementary level, and maybe with parents too, they thought, oh, well, they'll have their calculators, so we don't really need to emphasize that any longer, which is fine, except when you say, hey, tell me what numbers I can multiply together and get 12. Now they're stuck. So those times tables are still important. And then kind of going back to, I hate to keep, blaming COVID, so to speak, but I teach 6th and 7th grade is where most of my experience is. And so we're now seeing some of those kids coming up who missed out on such a large amount of instruction. And I'm looking at the OEQA report here from Oklahoma, and the number of people who attempted the reading specialist test so they could become certified to be a reading specialist, because that's a big need we have. 86 people took the test to become certified as a reading specialist, but only 6 people took the test for math. So I think we're overshadowed a little bit by reading and literacy, which is also important. But I think we've got more resources and more people directed that way than we do for math. And I think it's kind of a little bit of like what you were saying, where people think they can't do math or they're not comfortable doing math. And I've had several parents come to me, I don't want to teach them a wrong method. And I'm like, well, the only wrong method would be something that is wrong. I mean, as long as it's mathematically sound, help them however you know and however they understand. But I've heard from many, many parents who have been scolded by teachers that they need to do it this way. And yes, there may be some methods that are better than others and some that are more universal and might work for different kinds of problems like they were talking about earlier. But what I tell parents is, you teach them anything that is mathematically sound. But a lot of parents are afraid, they've got to do it this one way. And I'm like, no, if it works and they get it and you can explain it, then be my guest.
James, I saw you kind of nodding there. Do you have something to add?
No, just nodding in agreement rather than nodding off.
I am going to have to leave right now.
Good.
So I'm going to get off, but I enjoyed this session and enjoyed meeting Sandy and all of you. So,
And thank you so much for being there, Barry. We really enjoyed talking to you. Thanks so much.
Thank you. Bye.
All righty. Bye-bye.
I can stay on for a little longer.
Awesome. Then let's just continue, because I wanted to Julie and I probably have a little bit of a different, perspective, maybe, James, because we're very parent oriented, and we believe that if you have a child, then you parent that child, and that means even teaching that child at home. And we just feel like, that's part of the responsibility of a parent is, if you're going to have the kid, then you ought to even be able to be prepared to teach that child, because nobody can parent a child better than their parents. I mean, that's just, now granted, you always have outliers, and I'm not going to get into the outliers, but, according to the normal bell-shaped curve that everything seems to fall on, most parents are able, to do that without issue. And so that's kind of why, I've been asking questions more aligned and geared to parents, because I have seen over the years, and Sandy and I have talked about this on numerous occasions, because I've been in science, not math particularly, not specifically, but science, which has a lot to do with math and dovetails certainly with math. And I've just seen and I'm going to call it a dumbing down of what, we're expected to teach kids and what kids are expected to learn. And I feel like if parents are really interested in their kids being able to, do anything, one of the things they have to be able to do is math. And any parent can teach their kids math facts. And if you don't know those, perhaps you better help your kids with them, because then you can learn them yourselves. But I just think it's my mother used to do that with me, and I would scream and yell and kick and try to get out of the car. But she trapped me in the car while we were driving to do math. But I just think that's, so important. I mean, I don't know if anybody wants to kind of expound on that or not, or,
I think learning the math facts is really important. You got trapped in a car. I called it dirts, dining room table tears. Working at the dining room table with my daughter when I realized probably in third grade that she wasn't being taught she wasn't being taught the math facts in school. And so I thought, how fair is this that she comes home after having a whole day of school and I sit down with her and we work for 30 minutes to an hour on math facts, on her math. But and there really weren't a lot of tears, but there were times when it was kind of a struggle. But let me tell you, when she was in high school, she was expressing her appreciation to me for doing that, because she had classmates who that was their problem. They didn't have their basic facts down and they were struggling.
Just out of curiosity, and Sandy, I'm going to throw this to you. We've all seen ACT scores just plummet. ACT scores are down, SAT scores are down. I don't want to get into the politics of what the test actually means, but do you or do you not see kind of what I see, which is we're not covering the basics here. And so if you get on an SAT or an ACT test, just like we were talking about, and it's a timed test, you only have 20 minutes to finish this one segment. Mm-hmm. If you are sitting there trying to go 5, 10, 15, 20, 25, 30, what is 6 times 5? Then you're in a deep pile of doo-doo there. I mean, am I barking up the wrong tree?
I think there's a couple of factors come to mind. Like we talked about the math anxiety, and when a lot of parents come to me and say, oh, they've got math anxiety, they almost want me to take, the kinder, gentler approach to math with that child. And I don't know what that is. Now I can talk to them and calm them down and, get them to reason through. And I've had a lot of success with kids that way. When they start the year versus when they end the year, they're a lot more comfortable and a lot more confident in their skills. And that's really what remedies the anxiety, is giving them the confidence in the skills. So rather than, ignoring it and just hoping it goes away, practice and improve your ability. And that takes away some of the anxiety. Another perspective on that too is just call it another theory until I can work this one out. I think we introduce concepts in our standards too soon. And I don't think, as y'all discussed earlier, they're not developmentally appropriate, but we think, oh, that's a skill, in these lower grades, therefore it's been presented, therefore it's been learned, therefore we can go on. That's a lot of assumption. And so I think we introduce concepts that they're not ready for, but then we assume that they've learned them because they should have been quote unquote covered. And then when you look at some of our, big State Department benchmarks and our guidelines and our big goals, is for 50% of our kids to be fluent in the skills by 2030. Okay, so we expect half the kids to be, masters of those skills, but they're all going to go on to the next grade level. Tell me how we expect that to pan out.
Right. Well, and you talking about them using the calculators, that is just, I personally have stopped using my calculator unless it's like some big something and it's, money related that I need to be sure I've got it right. But I've started just so I have to think.
Yes.
Because math makes you think. And I just can't believe that teachers are encouraging calculators instead of doing the math work.
Right. And once they made that decision that they get to use them on the state test, that was the opening of the gate for all of them to be provided. And as you say, and again, dealing with middle school kids, they punch in things that they wouldn't have to if they would just stop and think, but they're just so used to that, almost a laziness, if you want to call it that, a mental laziness. They're going to punch in 3 times 2. rather than think about, oh, wait, I know that. And then, some of them do, they'll start punching, they'll go, oh, wait, I don't need to punch that in. Yeah, you're right, you don't. So, but then there are some of them who are going to punch it in every single time, even if it is 3 times 2. So it really has been a handicap.
I'm going to go back to what we talked about earlier is, we're not teaching kids spelling anymore either. And, Julia and I, oh my gosh, we climbed the walls about the time of Common Core when they wanted to get rid of cursive handwriting, because we had to make way for something else. Well, the problem is all of these things that we seem to be throwing out, the baby, the bathwater for the baby, all of these things that we're throwing out are things that are absolutely essential building blocks for kids to be able to understand. And what you said about stopping anxiety if you know what you're doing, you're simply not anxious about it.
Right.
I mean,
and success stops anxiety.
Right.
Now, to jump away from math, you mentioned, Jenny, a while back, something about diagramming sentences.
yes.
And I remember one year I was had a 3rd and 4th grade combination class, and of course, people had said, "Oh, you can't teach, don't teach diagramming. It wasn't, it would do harm to the kids and that kind of thing." And I actually had to look up how to diagram sentences because I had forgotten a lot about it, and so I got it figured out. And I taught my 3rd and 4th graders how to diagram sentences. They ate it up. They absolutely loved it. It was something they could look at a sentence and they could put their teeth into it and get the parts figured out, and they knew what was going on with it. Whereas before they really didn't. It put structure to it, and they liked that.
But that's what you said, Sandy. I mean, it's structure. The train cannot go if there aren't tracks on which the train can move.
Mm-hmm.
And all of these things that we've been talking about today, like, the guy's book, like traditional math, those are the rails on which the train moves. Mm-hmm. And if we're going to continue to take those away, then we're, we can't continue to push STEM and say STEM, 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 when there isn't a trunk for that STEM to come from. Right. And the trunk is all of these things that we're talking about that we don't want to do anymore because kids complain and we think that they're too hard for kids to do. It's just absolutely asinine because we're making it so much tougher for kids down the road to try to get anything accomplished when they don't have the building blocks, the basics, the track on which that train needs to run on in the beginning. So I don't know if we want, go ahead.
I was just because I think new teachers especially may struggle, as you're saying, because this is, frowned upon, it's shunned. And so if you're new to the profession and you haven't built up your stubborn, bullheaded tolerance like myself, you're going to think, oh, I must be doing something wrong. I mean, when it was, the curriculum fight and all that, NCTM responded back to me and said, well, I must be lazy because I don't want to change. I mean, you can call me a lot of things and I don't care, but lazy is not one you're going to get away with. I just felt like because I had a different opinion, because I saw it differently. I wasn't saying, my way is the only way. I'm just saying there is room for this. There is a place for this. And I've started teaching special education math in just the last couple of years. And if you think you're going to get one technique to reach a room full of kids, well, start teaching special education and you'll find out that is definitely not the case. So these people who think exclusively has to be this way, that doesn't make sense to me at all, because there is more than one way to get to the right conclusion. There's more than one, correct way to do it. So these people who just want to just pigeonhole and everything is tech and everything is on the screen, I think they're missing out, and our kids are missing out. Yet we push them forward, push them forward, push them forward, and then when they get to even high school or college, they don't have that grit or that stick-to-itiveness, or even the rationale of processing logically. If you can logically process through a scenario, that can answer a lot of questions and solve a lot of problems and ease that anxiety, even in areas you're not familiar with, if you can think and reason. But if you're so just used to, I only know one way and this isn't my one way, what do I do? I mean, then we've increased the anxiety and the rate of failure.
Dang it, Sandy, you opened up a whole different can of worms.
What, me?
Next hour.
It's so funny while you were talking, all four of us here, were in some form of the Common Core fight. And one of the things that I know that we've all talked about all throughout is all during Common Core, they kept saying, oh, we want kids to be able to think for themselves. We want kids to be able to reason. And yet so much of what we were seeing was teaching kids the opposite, not to reason. Here, do it this way. This is the only way to do it. You must only read this book. You must read this, manual for repairing the refrigerator. What you guys are talking about, James and Sandy, what you guys are talking about is what parents need to understand is the important thing. And what you just said, Sandy, is music to all of our ears, I know. And parents have to understand that you without an ability to think through this stuff, we get automatons that go, yes, I will do whatever you say. Yes, I will. I mean, we've got to have people who can actually think. So we're going to have to close out because it's 1:21, and as usual, we're over our hour. But I want to give you a chance. I'll start with you, James. To close this out, what's like something that you feel like you can say to parents, or you want to say about math or anything? We're giving you the floor here, bud.
Okay. I would say by the time a student leaves 6th grade, they should be fluent with their facts and able to use the standard algorithm for all 4 operations: addition, subtraction, multiplication, and division, with whole numbers, fractions, and decimals. And if they can if students can do that, they're in pretty good shape moving forward for future math classes.
That is awesome. Sandy, anything else?
I would just probably echo that sentiment. The basics are so important. I think even in elementary grades, there are some things we could re-emphasize that maybe we thought could be falling by the wayside. But I think as those kids have gotten older, we've hopefully proven by evidence that no, you have to keep focusing on those quote unquote boring rote basics, because if you don't, by the time they get to middle school level, then we're trying to teach multiple skills that they should already know in addition to what we are responsible for teaching them at that time. And so that just snowballs.
Right.
And parents, these are teachers that are telling you this. And so I'm going to say this one more time. This is the book, Traditional Math and Effective Strategy That Teachers Feel Guilty Using. Please look that up on Amazon, on Barnes & Noble, any place. Thank you. And Sandy has hers.
I love it.
And I have mine. Oh, Julia, we're going to have to get you a copy.
To get up.
So please get this book.
This book is something that
hey.
As we go to people start using computers, one of these days I just feel certain that we're not going to have access, and we're going to need to know math anyway. And I think that is just such a great book to have in your home, as like you said, as a resource, as a book to refer to when you're trying to teach someone math, because we have got to teach our children, whether we're a teacher, everybody is a teacher. Yeah. We're going to teach them something. Let's teach it to them right.
Amen. Everybody's a teacher. Well said, Jules. Excellent. Well, guys, I've had so much fun with
Mhm.
this particular podcast. I mean, parents that are still listening out there, I just, with my 5 kids, every time they complain about using math in real life, I tell them that math teaches you how to solve all problems logically.
Yes.
That's true.
That's
That's
true.
absolutely correct.
Yep.
Guys, thank you so much. James, it's such a pleasure to see you again.
Pleasure to see you and to see the other 2 of you and work with you today.
And Sandy,
Yes.
thank you so much for coming on. I really appreciate you so much. And I do want you to put in the chat, in the comments here, if you can put down how to reach you in case parents have a question.
Sure.
About standards even or anything else in Oklahoma, if you'll put that in the chat so that we know how to get in touch with you, I think that'll be super helpful. So
Yes, I will do that.
great. Thank you again, everybody, for joining us today. And Jules, always good to see you. And we have coming up on Friday, I did it again. Who do we have on Friday?
I can never remember when you ask me that, Jenny.
I know it's the same thing, same problem we have every time. But don't forget, we'll have somebody on Friday morning at 9.
It's another author. Another author. I do remember.
Okay. All right. Thank you so much, everybody, for joining us. And thank you, everybody, for being with us. And we just so appreciate it. And it was a great discussion. Have a great day.